So today's lesson will be the second section of logic, which is truth tables. So I will probably try to put together a video here doing about 4 or 5 of these, and then I might do an extra one beyond that. At first, though, let's go ahead and just look at some basic truth tables. Now, as you know, we've been looking at statements, and we've been looking at the symbols or, and if then. By the way, the definition of a truth table is a chart consisting of all possible combinations of the clauses in each statement. But before we actually do, our goal is to construct the truth table. We got a little bit of work to do. We got to go over the basic truth tables, as I call them. So there'll be one for and or. Excuse me, or and and. Now notice I have P and Q. So P and Q represent 2 statements. So it could be like maybe, let's just say you're applying to go to college somewhere, and P is a 21 on the ACT that you need to get, and then say Q is that they require a 3.0 GPA, or at least I guess. So if the college requires either a 21 on the ACT or a 3.0 on your GPA, then if you think about this as a truth table, if you do both, you get accepted. So true, true. But the thing about the statement or is only one of the statements has to be true. So if you get a 21 on the ACT, but say your GPA is below a 3.0, you still get accepted. And likewise, say you don't get the ACT requirement, but you do have a 3.0 GPA, well, that means you're still in. True, accepted. True is accepted. F would be not accepted. So if you fail to do both, you're in trouble with the or statement. It's false. Now, the only difference between or and is, if you think about it, we'll use the same scenario. So this college, say it's college B, and the second college you apply to, they want both a 21 on the ACT and a 3.0. Well, the only time you're going to get accepted is if you meet both criteria, which is, you get at least a 21 on the ACT, at least a 3.0 GPA, and true, you're accepted. All the other cases will be false. All right, and then just real quickly, going over reviewing, I'll bring it up on the slide. The arrow table, true implies true is true, true implies false is false, false implies true is true, false implies false is true. I know that probably seems a little bit awkward, but think about it this way. Say the parent says to the child, if you make straight A's, then we will reward you with $100. Well, think of that. So Q is rewarding with $100. P is making a 4.0. So the child makes straight A's. Parents reward him with $100. We're good. The parents met the agreement. But if the kid does get straight A's and the parents don't reward him after saying that statement, they lied to the child, or they didn't obligate the child. That would be false. Now, if the kid doesn't get straight A's, but the parents are proud of how hard he worked, maybe he got 4 A's and a B, and they reward him anyway. Well, that's still going to be that the parents still did not lie about their original statement. And then, of course, if the kid doesn't make straight A's and they don't reward him, obviously the parents still fulfilled their obligation. So the only time that the parents will fail to fulfill that obligation is if the kid does make straight A's and they don't reward him. That obviously will be false. So, and by the way, the negation, real quickly, true becomes false, and then false becomes true. So you really only need one variable for that table. All right, so let's do an example. The first example, and I'll put it up here and we'll work it together. We're going to actually now, using these values for the truth table, we're going to construct a truth table. So P and Q, or Q is my first example, and we have parentheses around P and Q. So if you have parentheses in your example, do what that is first. Now let me go ahead. I need to set up the truth table, so I've kind of got a little ahead of myself. Let me back up just a little bit here. Obviously, we have the statement we need to make a truth table for it, and we're going to do P, Q, and if you notice, I've been consistent in this pattern: true, true, false, false, true, false, true, false. And as you know, a statement can be true or a statement can be false. Something I probably didn't make real clear is, why am I doing this pattern? Well, it's every combination. Now, if you go T, T, F, F for P, and T, F, T, F, that is every possible combination for true and false. When you have two statements, there's 4 outcomes. You can have both true, first true, second true, none of them true. So that's just a quick way to do every combination. That's all that is. So again, I'm going to keep that combination. So T, T, F, F, T, F, T, F. That combination, again, gives me every combination. That's every possibility with P and Q where, those are two statements. Okay, so what we'll do now, I do each step in a column. So the first column will be to do inside the parentheses, and then the second column will be this part worked out, and then or Q. So that'll be the last thing, because we've got to compare these two results with or. Now, the way you do this is you're going to look each of these up on the table. So you will look up true to true on the the and table, which is true. Then you'll look up T to F is false. Then F to T is true, that is false. We have the wrong table. And F is false. And we do that because the only time it's true is with two truths. So one false makes it false. So that takes care of the inner parentheses. Then the next column is, we're going to compare this with Q using or. So T or T is true. Now, one thing about this, I noticed when I first taught this, a lot of people would make the same mistake, and what they would do is they would always copy this pattern. That's not going to always be true. If we're doing or, you've got to go row by row and look it up. So I got to look up T, T, F, F. So notice the order how I look it up is mixed. I do the first row, then I jump to the fourth row. F, F is false. And then T, F is back to the second row. That's true. And then F, F I actually repeat. It's false. And that's my final result. So you may repeat looking up. Notice that I use FF twice. So you don't always go this exact order. You just go by the order of what symbols you have. And you got to look up each row going across individually. I hope I made that clear. So T, F, T, F. Anyway, that's the first example. Let me do another one, and I'll bring up the result here. In fact, I'll just keep that up there while I'm erasing this, and we'll go to the next one. So, hopefully you got an idea after doing one truth table. What the idea is to just basically you'll set up P and Q with the patterns of T and F, which is T, T, F, F, T, F, T, F, or Q. Then you'll go across column by column each column will represent a step. Our book actually does that a little bit differently. And if you read through the book and like the book's technique, that's perfectly fine. You can use it. It's a little bit harder the way to do that, but anyway. Let me go to the next one, which is P and Q or negate P. So again, we'll set up with P and Q, and that's just given. And then what we'll do is go, again, column by column each step. Now there's a couple of things here in terms of there is kind of, it's not as clear cut as algebra, unfortunately. Where algebra, when you have like, you're breaking down, simplifying, there's clearly these order of operations that always works, and there's not such a thing in truth tables that is so clear cut. My suggestion is always do what's in the parentheses first, and if you have a negation directly with the symbol, you should probably do it first too. So in fact, you can always do that as your first step if you want. You just have the negation directly with the variable, and not where it's like, you know, outside of parentheses, but just directly with the variable. You can do it first, and then P and Q is inside parentheses, so we'll do it next. And notice that the thing connecting, the last thing we're going to do is this or, but it makes sense because we have to know what's in the parentheses first, and we have to know negate P before we can do the thing in the middle. So in some ways, you can do common sense. In other words, looking at this, you're saying to yourself, well, obviously I got to get what's in the parentheses first, and I have to know what negate P is. Then I can do the last step, which is the or. And there probably is other sites explaining truth tables out there, and if you find one that uses the same technique, feel free to use that, because I don't know how, you know, I hope this video will be helpful, but this is a little trickier thing to do. And usually in the lecture I get a lot of questions on this unit, and my students asking me a lot of questions helps the class go and people learn. But where it's just a video straight out, it may not be quite as effective. But I'll just go over the basics, and then you listen in. If you feel like you have to go to another site and go through it, then do that, because there might be another site that has a better explanation. Anyway, the negation of P, you just flip. As you might guess, the negation of P, you just do the opposite. So TT will become FF, and then FF becomes T. So you just change T's to F's, and then F's to T's. And of course, and will be true. And remember, those are false. Remember, one false on the table will make it false. So TF is false, FT is false, and then FF is false. It actually goes in the same order in this case. Not always that. Doesn't always do that. Okay, now we're going to do the or in between using these two columns, because we're doing P and Q and negate P. So we're going to do F or T is true. Actually, that would be T or F, but that's still true. And then F or F is false. F or T is true. And then F or T again is true, looking at the third row. So the final result in my answer to my truth table is T, F, T, T. I may have not explained that real well, but once you complete, on the first example, once you complete that last column, you got the final result. And this is your answer to your truth table. So that's like your final answer. It's that last column as you work it across. Okay, it'd probably be helpful to do this one. Pardon me. So, negate P or Q. So we're going to do P, Q. which we always start with, and then T, T, F, F, T, F, T, F. So on this example, the question is, what do you do first? Well, I mentioned about the negation. If it's directly next to a parenthesis, you have to do what's in the parentheses first. I'll say that one more time. So if you have the squiggle negation, if it's directly next to a parentheses like this, you've got to do what's in the parentheses first, which is P or Q. Then you can negate it. So we're going to do, or would be, looking up the OR table, it would be true, 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 false. It's basically the same order. And remember, another thing about OR, one true makes it true. But that situation where two falses will be false before. And then we just flip it now. So to negate the result true, 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 false, we just simply switch the truths to falses and the false to true. So this becomes false, 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 true. I'm going to leave number 4 for you to work. I'll do this number 5, and then I think I will make this the last example in this video, and I'm going to maybe make a second one and give some pointers. But for right now, this will be the last one we do. So on the playlist, there will be Truth Tables Part 1 and Truth Tables Part 2. So we got negate P or Q, arrow negate Q. Now, we got a couple things going on here. Let me get it set up first. This one looks, you're saying, well, that looks a little more tricky, and it probably is. But notice what we have here. We've got a negation directly next to the parentheses, which tells me is I've got to get P or Q first, then negate it. So I know I'm going to have to do that in the table. Also, I have to do negate Q. Remember, negation's by itself with the Q. So it appears the arrow will be the last thing I do. So actually, there's two ways you could do this. You could do P or Q, and then do the negation of it, and then do the negation Q. But if you like, you also could do negate Q, P or Q, and then negation of P or Q. The thing is, though, you got to get these two results. You got to get the negation of the quantity P or Q, and you have to get the negation of Q. Those two have to be completed in some way in your table, so you can do the last step, which is the arrow. Which, all right, there's the last step. So, P or Q, again, is, if you look it up, true to true is true, true to false is true, false to true is true, and then false to false is true. So this will be T, 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 F. Okay, and that's from the OR table. Negating that, you would get false, 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 true. Hopefully by now you got the negation. Now you just change, you just flip it. So when you negate Q, it's going to be false, true, false, true. So once we have that, we're almost done. We have to do this arrow. Now, arrow, the direction does matter. Because if you go from true to false, it's false. But false to true is true. So your orientation is important. So T is first with the arrow, followed by F. It's false, but F followed by T is actually true. So we're going from the P or Q with the negation to negate Q. So we'll read the table this way: F to F, F to T, F to F, true to true. So F to F on the arrow table, we haven't used it yet much, is true. False to true is true. Going back to the fourth row, false to false is true. Again, I repeated looking up rows. That can happen often. And then T to T is true. So it turns out that my final result is true, 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 true. It's all true. In logic, there's a special term for that. That is called a tautology. Where it's all true. And I did my tables. Notice I did in the notes a slightly different order. I did negate. Ooh, should that have been negate Q? No, actually I have a mistake in the table. I got to fix that. But anyway, I think it actually is correct. I just think I need to make that a negate Q. And these are older notes. I had the chord's not working, so I had to pull up an old set of notes, and that probably has been corrected by now, but I'll go look that up. If it isn't right, then I will get that fixed. It should be negate Q. Anyway, I knew there'd be technical difficulties at some point. So, let me stop here, because I feel like what I can do is break this up into 2 videos. I'm afraid it'll be too long, and YouTube kind of gets a little fickle when I get about 15 minutes. So I am applying the live streaming though. So I can't go over that amount, but I'm trying to limit anyway. All right, so we will have a Truth Tables Part 2 that will be posted.